That's the finished product. That represents a lot of toil and a lot of determination. But the mud ring, we've got a few big 10-inch rivets we've got to put in, but all of this new riveting all the way up to the front of the boiler on both sides. 154 stay bolts here, 154 here, 73, 73, 4 more over here, a grand total of 589 stay bolts. And whenever we do one, we jokingly, somebody on the crew will go, 1. You know, when we install something, we're there working on it for 15 minutes and we'll be done and somebody will go, 1. You gotta have fun. And here's that full penetration welded bolt. My 2 Boilermakers are just outstanding. And the quality of work that they do is evident here. And the other welds that you see. A full penetration weld is just that. That weld goes all the way through the sheet and ties into this bolt. A very strong method of attachment. And at 300 psi, that's what you want. And here's some of our rigid stay bolts. In one day we did 75 of those. And this is on the back door sheet. And they're threaded through and then they're worked over in this manner here. They're driven over with a special tool that we've duplicated, known as a stay bolt driving tool. The UP has all the drawings. We've simply made those tools exactly to the drawing so we could use their techniques, their methods. Here's that telltale that I was mentioning to you, where you can see through the outside. And that's how the water was coming from that injector telltale and the blowdown water glass drains. It was coming through those holes and saturating all of that metal plating. The locomotive would sit around all winter with a wet firebox. And unfortunately, Mother Nature took its toll and degraded that plate. You can see those beautiful welds right above that. Here's our stay bolt driving tool, again drawn in CAD. We can send that off to some tool manufacturers that we have working with us. And this is a device known as a porous plug. And it's something that hasn't been used, to my knowledge, in a long time. We found a small supply of these over in the roundhouse, where even still today, we find all kinds of treasures. We find air motors and tools and drills and reamers and all kinds of neat things that have been sitting over in these steel bins, and they're rusty. Haven't been used probably since the steam era. And we've got one of our guys, he just loves that. It's like his birthday whenever he gets to restore one of these little parts. So what we're doing is we're making this particular device, and this is important. Because what the porous plug does, I'm going to back up to that. This telltale hole here is your means of determining when the bolt is broken. This side of the bolt is covered with a cap, either welded on, as I'll explain in a minute, or a threaded cap. This in here is at a location that you can visually inspect in most cases, unless it's behind arch brick or a fire brick or grate bearers on other locomotives. So when this bolt is subjected to load, over time it can fatigue and fail. That crack propagates through this telltale hole, and you'll get either a large blow of steam if it's a big crack, or you'll get a small appearance of leak. You're going to get water or steam or scale. That tells you that that bolt is broken. Well, that porous plug serves an important purpose because it sticks in the very end of it, and it doesn't let that sand and soot and dirt and everything get in there and plug that hole up. Because if that hole plugs up, some would think, well, the steam will just blow that gunk right out of there. If it's a small fracture, not really. So that's part of the regulatory process that we still have to follow today. So that porous plug is very important. Now back to the stay bolts here. This is an actual UP drawing of bolts known as the Flannery design. That's the bolts we use. And you can see how these stay bolts are applied. This shows the threaded. This doesn't have the full penetration weld. That's something that was redesigned in its last rebuild. And so far it's working out very good. So instead of this threaded installation here, we have that full penetration weld. but all the different styles of sleeves and caps. This is called an MKS. I'll talk about those. I have one over here, a brand new one that we've made. And I also have these sleeves. All the tools that we've made. It's kind of fun when we get pallet loads of these components that we're having made. We'll buy the code material, and then we'll draw it in CAD, and we'll have a lot of back and forth with the shop that's going to make it for us. And they'll make us a few test pieces, and if they qualify and we approve them, they'll mass produce a whole bunch of them for us. And they show up in these, big truck shows up, and we forklift these things off of there. We're all over there going through them, looking at them. I put a bunch of them on my desk. They're really neat. And there's a KJ flexible stay bolt. We put some layout dye on there just so we were doing an experiment. We wanted to make sure that it fit the way it was supposed to. And there's one of those big boxes, all heat treated, case hardened, ready to go. And that center part, in half of this part on the right side, we've already installed in the locomotive. All three of those compartments were full to the top. And here's some stay bolts. The center one came out of the 844. This one came out of the 4014. This was a piece of stay bolt stock that we had in the shop as part of our inventory. And we did an experiment to determine where the telltale hole was, because you want it to be as close to the center. Well, unfortunately, this one is a little bit off, so we're not going to use that one. We also don't have the paperwork on this, therefore we can't use it unless we go through a process to qualify the material. And because it's not made really the way that we were looking for, it's not really usable for us. We're just going to make new parts. Unfortunately, this one doesn't have a telltale hole. That came out of the 3985. And I've got that one over here. But again, just going through, just doing a little bit of investigative work, looking at things, verifying it's this way or maybe it's not. Here's one of those stay bolt holes, looking through to the inside of the firebox. And here's the new KJ flexible stay bolts all in the back corner. Every one of those is inserted in here, held securely, and then welded on the inside with that full penetration process. Stay bolt sleeve. Some of these sleeves we had to cut out and replace new. As we put the new firebox plate in there, we make a template out of lighter gauge steel that we can form, and we can machine it a lot easier, and it's certainly a lot easier to lift in the locomotive. Then we confirm that all the stay bolt holes are lined up as they should be. And if they're not, we have to make an adjustment somewhere. So we're going off the original blueprint. Well, regretfully, some of these sleeves were a little bit skewed, so the bolt would not fit through and match up to the hole. So we had to cut those out. And again, that's something you're not going to discover until you put the locomotive together. So that was one more thing we had to add to the to-do list. We had to cut those sleeves out, condition the hole, weld them back in, and then proceed on. Here's a drawing of what's known as an FRW sleeve. That's a countersunk design. And now we're going to talk about those turret valves I was talking about up front. Heavily rusted, old, seen many, many years of service. A tribute to the designers of Union Pacific and American Locomotive Company. I mean, this stuff is just rugged. If we built our automobiles the way that these locomotives were built, every one of us would still be driving our first car we ever owned. They were just absolutely a tribute to the engineering. But think about 300 pounds of steam pressure and 425 degrees. You know, that steam is extremely powerful. So we go through and disassemble it. The top is what's known as the stem. And that operates through this threaded part of the bonnet. And this bottom part is the valve. And pitted, really old. It probably put it back together and work, but since we're doing it, let's just make new parts. So one of the other things we just add to. And we factor this in when we're going to, one person is assigned that job, and however long it takes him, that's what it takes him. You know, I'm not hovering on him, hey, come on, no, that's good enough, let's go. You know, whatever it takes to get it together and make it right. Because again, this is a 30-year plus rebuild. And there the turret valves are now. All new studs. This is that stem right here. New packing nut, new gland. All new studs, nuts, all new studs here. These are machined. And that operation takes a long time. And that's just how steam locomotives are. You know, if you're looking to just get it together, if you're looking to, come on, this is taking too long, it's probably not going to work out too good for you to work in that shop because it just takes a long time. We got to set that hole. This picture doesn't do it justice. This turret valve is this big. It's huge. So we've got to put this thing, we've got to make a fixture plate, set it up in a mill, and then actually machine that fit up there. And it'll last, probably outlive me.
Original casting?
Yes. Near as we can tell, in the steam era, these parts came on and off engines when they were in service. They'd pull something out of inventory, this component would be rebuilt, put back in the stores. But that's been with the 844, as far as I know, since it was placed in the service it's in 1960. This is an internal part of that. It's a guide. We made those new. This is a washout plug, one of the old ones. And this is the new washout plug. And I brought one of those over there. So we go through, and as you fit those washout plugs, the same thing. We got to make a cutter. We got to make sure the threads are what they need to be. And that cutter fits in those threads, and it cuts that seat that plug mates up against. So it's just a long, arduous process. Something that you want a very detail-oriented machinist working on. You don't want them over there with a grinder or a file, you know. You want them to really do good quality work. Because these plugs are not designed to be beat on. But even though they clearly have been. and that's not meant as a joke. I mean, steam locomotives are rugged. This locomotive's been around a long time. Sometimes things leak. And a little tap period there sometimes is what it takes. But when you've got a plug or a valve or something with steam pressure on it, boy, you're sure taking your life in your hand if you're going to start wailing on it. So it's time for that plug to be placed in the museum. Now we've got some more cutters, and again we go through and you're making all these devices and all these tools, and this tool doesn't work, we've got to modify it, and you just go through a very long process. Little by little, working her together. And we make another cutter. And this is really going to come in handy on the 4014 because the 4014 has mostly the welded style of caps that you can come look at here when we're done, known as an MKS cap, and that's welded on. That welds on all those round protrusions that I was showing you. Well, that's what the big boy has. Well, how are we going to get them off of there? With a torch, a plasma cutter, a hacksaw, a grinder? We made our cutting tool, and we can't take credit for it because we get on the internet and we research the patents of what they made. And this is the actual cutter that they made. How did we find that out? Well, because we got the books. So we do a little bit more research, and we got some pictures of it. Because it's proprietary, they don't really give you good drawings. So with a little bit of work on our smartphones and Google, wouldn't you know it, there's the patent. And it's expired, so let's just make it. And it worked beautifully. And there we are. And we, yeah, that poor guy, for weeks, he's up there addressing every one of those seating surfaces. While we have the caps off, we test the bolts, we check them 6 ways from Sunday to make sure there's no issues. And there was a few of them that we changed out. There were some of the caps that were welded on, unfortunately. And that's not something that is authorized. So we had to carve those things off very diligently to break those free and then address the condition that resulted in it being welded on there so it would seal correctly. And there's the top check valve. The casting in it too, completely rebuilt, all new studs. We had to make a couple of specialty taps there. There it is installed on the locomotive. All new studs on the top, new caps. And these are the studs that hold it on there. And there's a device known as a diverter or a diffusing plate down below here that takes that water as it enters the locomotive and it hits that plate and kind of sprays down into the body of water in the boiler. We needed to address this because just over time, it's hard to say when that had been off of the locomotive the last time, just because of the deteriorated condition of everything. So it's hard to tell some of these things. So when we take it off, we've got to correct that. And that's what that blue is. It's a dice that gives us an indication of how well our machining worked out. And now we're going to get into some of the piping and air brakes. This up in the right corner right here is an air filter. And it's got a filter element in there that needs to be changed as much as you need to change it. But by federal regulation, it's got to be changed every 368 service days. And you've got to look at it on an annual and other inspections. That's the air brake pedestal. And that's where the air brakes mount to. That's the automatic brake valve. Some of these, if you guys watch the internet, I made a little video here just a week or so ago, and I included some of these videos in that video update that we produced. That's the underside of that. And again, it's required that these have to be gone through. It's an air brake component. It's regulated by the FRA. You've got to go through a specific work scope. Doesn't matter if it's a steam locomotive, air brakes or air brakes. You got to work on them. So we went through, got it all cleaned up. We were very fortunate that Westinghouse Air Brake, when I reached out to them some years back, I had a contact there, and they had been following the Big Boy project. And this individual is, much to my surprise, quite an enthusiast. And so we got the dialogue going, and they were able to get a hold of the rubber plant. And for the first time in my memory, they said, yeah, we have these old molds. Let me see if we can make them for you. Because previously, when we'd asked about gaskets, oh, that's obsolete. No, we can't do it. So I just kind of had figured out, we're just going to have to figure out how to make these gaskets. They were able to make a lot of the old number 8 gaskets for us. So that was really neat. So we have the actual Westinghouse brand new 1940s gaskets. Yeah, from Wabtec. Yeah. So our hats off to them. And again, going through this is a detailed job where you really want somebody who's patient, going to go through and really painstakingly clean everything up. Almost like taking apart a fine watch. Inside there's internal bushings. This represents one of the last locomotive air brakes utilizing the rotary type valve. The newer systems, not long after this system was in use, employs a much more, different, more modern technology. Well, these rotary devices, of course, they wear, so we took the bushings out, put new bushings in. So there again, I mean, this air brake system, and it's the same air brake we have in the 3985 and the 4014. So we're going to rebuild all that the same way. We already have all our own tooling and gaskets. So coming together, here's some of those brand new Westinghouse gaskets right there with the Westinghouse name on it. A box full of little wasp traps. This is a valve inside what's known as a distributing valve. And that is a very important part of the system. It didn't look like that when we took it apart. And there it is inside the distributing valve. And back here you can see we've got that internal area there all cleaned up with a special insulating varnish. There's a feed valve. That controls the pressure to the brake pipe. Very important. It's a high capacity regulating valve. And that's what it looks like when she's all ready to go back together. That's one of the gaskets that clearly wasn't serving its purpose. But there again, a tribute to the locomotive design. It's amazing that stuff still works. You know, and it's designed that way when you read the air brake books. And Westinghouse put some very comprehensive booklets out to train, mainly geared toward engineers, the operating aspects, but there's a lot of good mechanical information in there. It wasn't the rebuild manual, but it explained how those things work. Here's that filter I was talking about. I don't think they've made that filter for a long time. And there's the new version. Yeah, we put a K&N filter in there. Those hot rod guys in here. That's the cab signals. Very, very important part of the locomotive. And here's the rebuilt version. And we'll take that, and that will be the same device that we have on the big boy. We've got all our parts, all the magnet valves, all the check valves, everything. We've got duplicates of everything, probably times 2 or 3. We've got plenty of spare parts. We're going to rebuild one system, we're going to make 2 or 3 others. Brake application valve, all rebuilt, all new fittings. This is the throttle. Now some people are probably going to be upset when I tell you this, but what are you going to do? Are you ready for this? Okay, I nickel-plated the throttle. As we were taking this apart, I mean, I have to say, I'm just humbled that all of us had the opportunity to work on the locomotive. I've run this locomotive since 2005, and I've run it thousands and thousands of miles all over the place. And what a grand machine it is. So that throttle represents a lot to all of us, and it's such a magnificent machine. You know, to me, to a lot of us, this is the railroad equivalent of Air Force One. This is the heritage of our railroad, and I like to say our nation. You know, it's a very important piece of equipment that we're responsible for. So we give it its due respect and attention, and okay, I nickel-plated the throttle. And I also nickel-plated the reverse. And I believe that's it. The question was if we've had to cast anything, and we have. Yeah, we've used some foundries. They're steam bronze. In this case, we've got other parts that we've made. We've cast to those parts. We make it just the way that they're made. They're designed to be made. Sometimes we have to do a little bit of reverse engineering. We'll take, and oftentimes when we're not sure, especially if it's code material or if it's a component that has to be made out of code material, we'll take a sample of that and we'll send it off and we'll have it analyzed. They'll put it through a spectrograph and they'll give us the chemical composition and a certified report so we can certify what it is. And from that we know what material to make it out of.
Are you going to take any parts from the 4004 for the 4004 rebuild?
The question was, are we going to take any parts from the 4004 in Cheyenne? The answer is yes. And that was, it wasn't a big factor in restoring a 4000, but it certainly was something that you had to consider, that we only have one more 3900 class big Challenger, and that's the 3977. And we don't have many FEF3s or other locomotives that we can use for the 844. So, but we do have 7 other examples of 4000 class locomotives. And so we do have a source of parts. They're not brand new, but it is a source of parts for us. If it's a component such as this actually came off the 838. One of the locomotives we have in Cheyenne. The 4005, the 4004, all the 4000s have lots of these. And so that's something we're not going to have to duplicate, because we have opportunities to reach out to the owner of those locomotives and see if we can't work something out. That's a good question. That's a good question. We do want to have the 844 done this year. That's what we're pushing for. And the 4014, we're pushing for 2019. And as I mentioned, we've got a lot of the materials that we bought. We've got timelines, and we've got a lot of concurrent activity going on. But there is 8 of us. So, you know, but we're very confident that we can progress this.
Is there a chance the 844 is going to be done by Cheyenne Frontier Days?
That's another good question, and that's what we're shooting for. This year, bear in mind, we've got to do some break-ins, and this is one of these things where, you know, we wanted to have it 2 years ago. I wanted to have it last year. But the reality of it is that we have conditions that we've got to address. And, you know, they understand that. This is the heritage of our fleet. It's the pride of our fleet. But it has to be done correctly. Yes, sir.
You're saying that the replacement lagging tended to saturate with water. Did its predecessor, which I assume was asbestos, was that equally likely to saturate or a little less so?
Well, I can't really speak to that because although I've seen asbestos on locomotives, and yes, it does retain water, it's just the nature of the cycles of maintenance that locomotives undergo and the service that they're under. And again, you know, the other factor is the longevity. I mean, these locomotives were projected to live into the 1960s. They were able to dieselize by 1959. There were plans before World War II, they were going to be dieselized much sooner. So as these locomotives were on the drawing board and being produced, they had no idea that it was going to live into its 70s. So that is another factor there. The insulation that we'll use is a very common insulation used on most steam locomotives, and it just comes in a block form. You know, it's not waterproof. It does get wet and it does break down. Yeah. But that's why it's important to have a couple of things. A good secure jacket, because we do wash it and it does rain. So the other part of it is when the locomotive is in service, the external part of that boiler is very hot, considering your steam pressure is at 425 degrees, your temperature. But when you put the locomotive away, that is the most important part of the locomotive's life, because water does what it does. And there's so many little intricate parts of a boiler, even though the thing looks massive and huge. There's so many little bits and pieces of it, all those threaded, thousands and thousands of threaded connections. Every one of those tube installation points, all of that can corrode, and it will corrode. So what you have to do is you've got to reduce that. The atmospheric oxygen continues to drive that corrosive process. If there's water present, the atmospheric oxygen oxygenates that and sustains that level of corrosion. You've got to stop it. What we do is we heat it. We got these big giant heaters in there and we smoke that thing. We get that firebox absolutely smoking hot.
Dry everything out.
And when we wash it, we don't go home until it's hot and dry. And we make sure we've got lights that indicate that we've got this thing on. You go by that firebox and it's hot. We got the washout plugs out. I mean, we're smoking it. Take the superheaters out. I mean, all of it. It's a lot of work. That's why you don't see a lot of steam engines running, because they are a lot of work.
Also, is 844 ever going to get its Mars light back?
You know, I was kind of funny. I don't read a lot of stuff on the internet because it's so true. But the Mars light kind of came about in a unique way. We were in Council Bluffs and we were looking, and there's some studs that hold it to the smoke box door, and several of them were broken. And that Mars light's big and heavy. Yeah. And so we went in and just took it off. And I thought about taking the elephant ears off and everything else, but we just don't have a lot of time for that. And I like the elephant ears. But yeah, we'll put the Mars light back on. But we decided to, what the heck, we wanted to see how long it would take for somebody to notice. And
there was a true Mars light.
Yes. Yeah. A pile gyro light. Yeah.
Are you close to a hydro test?
Pardon me?
Are you close to doing a hydro test?
Yes. Yes, we are. We'll be stuffing tubes in it starting tomorrow. So we've painted the inside of the barrel of the boiler. I've got some other photographs that I didn't include because it gets real long. We cleaned the inside of the barrel of the boiler. We had to shorten several boiler braces. You know, that's the only time you can do that level of work, and when the tubes are out of it. So there were some tube sheet braces that were a little loose, and as required by the way it has to be, we needed to tighten those up. We did that months ago. But just one little thing at a time, you're just kind of progressing yourself toward getting the locomotive together. No, I do little video updates.
Oh, okay.
As we progress the rebuild, yeah, we're going to put some more videos out. They're all Hancock 3 chimes, and ironically, that my friend Ed Gerlitz that I mentioned at the beginning of the presentation, he had a vast collection of whistles, headlights, and all kinds of railroad stuff. And in his collection, he acquired several Hancock whistles, most of them through a purchase type of arrangement. But to answer your question, it's a Hancock. The whistle on the 844 is actually off of a 4000. Ed, before we announced the 4014 project, before it was even in the works, I was trying to nail him down on which 4000 it came off of. And he would just, oh, it's so long ago, why do you always do this to me? And so we've got the 841, we've got the 4014, plus the whistle that was on the 4014 when it left in 1961, but who knows what whistle that really came off of. But the whistle that we have on the 844 comes from the Ed Gerlitz collection, and as you and I can attest, it is loud. The one that was on it previously was just steam cut, and it kind of had a raspy sound to it, and we wanted to work on it a little bit, but we just didn't have time to remachine it, so we just simply replaced it with that whistle that was currently on it. And it'll stay on.
Yeah.
We might switch it around. The 3985 has a whistle that's been on it for years. I love that whistle. It has a very prominent low tone.
Yeah.
And I like a single note whistle personally, if we want to talk about whistles. If I could admit to being a guy that likes trains. But that 3985 whistle is, it has a really nice sound and a lot of fond memories. I've operated that locomotive a lot, fired it tons. It's a tremendous locomotive.
That one's on hold for now then, right?
It is.
Indefinite or likely eventually? they'll run
One
out?
never knows. You know, I certainly don't like to use the word indefinite or permanent or anything like that, because if you were in a position such as myself and you had superpower locomotives, would you run them? Would you restore them? And you know, I think everybody would agree. Yes, certainly. It's a tremendous representation of that locomotive. It has a great story behind it, how it was restored and brought back to service. Great people got together to restore it. For many years it served as an ambassador, and a great one. So it's a fine locomotive. We look forward to doing everything that you see here to the 4014 and the 3985.
Yeah.
Imagine having a roundhouse with 3 of those things steamed up.
I recall reading in Trains magazine probably 30 years ago, they were talking about 4499, an editorial about keeping it maintained without any deferred maintenance.
Yeah.
And they were talking at that time about $1,000 an hour of running time.
Yeah, I've pretty well figured out what it costs to run those things, but I certainly don't like to talk about it. You know, I mean, realistically, why would you want to run a steam locomotive? Because they're fascinating, and it's a great ambassador. It's a great tool. Yeah, we can talk about it from that standpoint, but realistically, it's a steam locomotive running today. You don't need to be a train buff or a rabid rail fan photographer. They are just really neat machines. They're absolutely one of the best ways to reach out to people. They don't even realize you're reaching out to them. I mean, the locomotive rolls into town. The thing is so enormous, it's alive. I mean, it feels like it is. It's just the magnitude of a steam locomotive, the fact that everything on it is hot. It's designed to be hot. It's not breaking down or wearing out. But it's just a really neat thing. The whistle and the sound it makes, the exhaust, well, it just captivates people.
I thought the whistle was kind of sick on the 14. Was that low pressure, low air pressure? Or?
That's because a diesel was making it work. It was protesting. we had this is a little bit of a story, and I told it before. When we wanted to blow the whistle, but we only wanted to blow it the moment that we came out on the American Railroad Network. So it took a lot of discipline for us not to toot that thing every now and then as we were coming across the parking lot. So we put a big air reservoir off of an SD70 locomotive, put it on the tender, and we plumbed it all up, and we ran that main reservoir air pressure from that 4884 diesel behind us. And as soon as we came out on the main line, I had it all worked out in advance that Paul Gershio, he was one of the members of the museum, it was up to them who blew it, but one of their museum staff was to blow the whistle. And they were a bit timid at it, and I told them to do it again. I was on the radio, and just before we started to move, the whistle wasn't blowing, and I reminded them. And then I realized I was standing right next to it, because I was on the front, and before I could put my hands up, that whistle blew. All righty. Well, thank you, everybody.